Good everyone. Welcome again. Still on complex numbers. Into this session, we will take a look at the modulus argument form of complex number, also known as the polar form. So how is this done? Now let's draw the 2D graph, the real and imaginary axis. Then if this is the points, I told you guys the complex number is equal to x plus I, y. So which means there is a x value, okay, and a y value, isn't it? Now, then this is the complex number, which is z, okay? Now, we can find the modulus of a complex number. So the modulus of a complex number is equal to the radius of that complex number, and it can be computed as the square root of x squared plus y squared. Okay, so this is r, which is the modulus of z, which is equal to s squared plus r squared. So if you follow this is a right angle, so if you follow the Pythagoras theorem, you will notice that r is equal to square root of s squared plus y squared, and that cos, this is the angle, also called the arguments. Okay, let me call this alpha, or let me call this theta, which is also called the argument theta. Okay, so cos theta is equal to opposite, cos is adjacent over hypotenuse, isn't it? So the adjacent is x, then this is x over r, and sine theta is opposite over hypotenuse, so this point is also y, this point is also x, isn't it? So y over r, and tan theta is equal to opposite over adjacent, which is y over r. Okay, these are just gotten from Pythagoras theorem, Socrates. Now, one thing you need to note about this angle is kind of a little bit complex and complicated, but it's also very simple. It's just that you just need to understand how it works. So this angle is always measured anti-clockwise and not clockwise. It is not this way. So you can see my arrow is measured anti-clockwise. Okay, having understood this, then we'll move forward to finding the value for x. That implies that x will be equal to r cos theta, and y is equal to r sine theta, and the theta, which is the argument, is equal to arctan of y over r. I hope this is well understood. So arctan of y over r. Oh, that was a mistake. I said tan is opposite over adjacent. Adjacent is x, isn't it? So it should be y over x and y, not y over r. So this should be arctan of y over x. So this is now corrected. I hope this is well understood. Okay, good. So after this is well understood, remember that we used to write complex number as z is equal to x plus I y, isn't it? So this can also be called the rectangular form. So that means that you can also write x in modulus and argument form, which is also called the polar form, as z is equal to, the value for x is r cos theta, isn't it? Plus I, the value for y is what? R sine theta. I hope this is understood. So that implies that z is equal to r is common to both sides. R, then what do I have left? Cos theta plus I sine theta. So this is complex number in polar form. Polar form. I hope this is well understood. So one thing that is very funny is everything we did earlier in the rectangular form can also be done with the polar form. The addition, the subtraction, the multiplication, everything can also be done. So let's do them one by one to see how it can be done with the polar form. But before we do that, this theta, this angle theta is called the argument of z. Okay? But you may be asked to find the principal argument of z. Principal argument of z. Because this lies between minus pi less than theta less than or equal to pi. Don't worry if you don't understand this properly. Let's take a look at this. To get this principal argument of z, this is what you have to do. Draw the 4 cardinal points, okay? At the first quadrant, the principal argument of z, which is alpha, I will denote this as alpha, is equal to arctan of y over x, okay, in the first quadrant. For the second quadrant, the principal argument of z is equal to arctan of y over x plus pi. That is how to get the principal argument um of of um of of z, principal argument of z in the second quadrant. And in the third quadrant, alpha, which is the principal argument of z, is equal to arctan of y over x minus pi. And in the fourth quadrant, the principal argument of z is equal to arctan of y over x. So if you are asked to find the argument of z, just find argument of z is theta, which is equal to arctan of y over x. So this is the argument of z. I hope you understand that. But if you're asked to find the principal argument of z, that is alpha, that will be equal to arctan of, it depends on what quadrant the angle falls in, okay, or the complex number falls in, rather. It depends on what quadrant the complex number falls in. If it was in the first quadrant, it will be equal to arctan of y over x, second quadrant, third, and fourth. So I hope this is well understood. So let's solve these examples to illustrate what I just explained. So you are asked to write the complex numbers in polar form. So these are complex number, x plus iy. You are asked to write this in polar form. So for the first question, you know that x is 4, y is 3, isn't it? So you have to find the modulus of z, which is r, which will be equal to the square root of 4 squared plus 3 squared, isn't it? So that means r is equal to, that is x squared plus y squared. So this will be equal to 16 plus 9, 16 plus 9, which is equal to the square root of 25. That implies that the value for r is equal to 5. Okay. So if you take a look at this, it depends on if you're asked to find the argument or the principal argument. So to find the principal argument, this lies in the first quadrant. How? Just sketch. Okay. X is positive. Y is also positive. So it lies in the first quadrant. So for it to have lied in the first quadrant, that implies that alpha is equal to arctan of y over x. I hope this is understood. So that means alpha is equal to, and don't forget that argument of the angle of a complex number is measured in radians and not in degrees, okay? So that implies that alpha is equal to arctan of y is 3 over 4. So you put your calculator in radian. Don't forget, put your calculator in radian, not in degrees. Then you press arctan of 3 divided by 4. And that should give you 0.644 approximately to 3 decimal places. So that implies that 4 plus 3i in polar form is equal to 5, okay, cos 0.644 plus I sine 0.644. I hope this is well understood. So this is the polar form of 4 plus 3i. Now the second example, which is minus 1 plus I. So like I told you earlier, find the modulus, which is equal to square root of x squared plus y squared, isn't it? So r is equal to square root of minus 1 is 1, minus 1 square is 1, 1 square is 1. So this gives me the square root of 2. So just leave it in an exact form, which is root 2. Now, the next thing is to find the what? The principal argument. So if you take a look at minus 1 plus I, sketch to see the quadrant which it exists. X is negative, y is positive. That means it exists in the second quadrant. And in the second quadrant, alpha will be equal to arctan of y over x plus pi, isn't it? So that implies that alpha will be equal to arctan of, what is the value for y? 1. X is minus 1 plus what? Plus pi. Okay, so this is equal to arctan of minus 1 is minus pi over 4 if you use your calculator in radian form, plus pi. So that implies that the value for alpha will be equal to 3 pi over 4. Okay, so this means that minus 1 plus I in polar form minus 1 plus I in polar form is equal to root 2, okay, cos 3 pi over 4 plus I sine 3 pi over 4. So this is that in the polar form. And the third example, you are asked to write this in polar form. So the modulus r is equal to the square root of minus 1 squared plus minus root 3 squared, isn't it? Okay, good. So r is equal to minus 1 square is 1 plus root 3 square, of course, minus square is positive. So this gives me 3. So r is equal to root of 4, which is equal to 2. So the modulus is equal to 2. Now, let's just sketch this to know what axis this lies in, what quadrant this lies in. X is negative, y is negative. That means it lies in the third quadrant. Okay, in the third quadrant, we know that the principal argument is equal to the arctan of y over x minus pi, isn't it? So that means that the principal argument is equal to arctan of y is minus root 3 over x, which is minus 1, minus pi, isn't it? So this gives me alpha is equal to arctan of minus cancels minus, then I have root 3 minus what? Minus pi. So alpha is equal to arctan of root 3 is, so arctan, or don't forget your calculator should be in radian, is equal to 1 over 3 pi, then minus pi is equal to minus 2 over 3 pi. So this gives me minus 2 over 3 pi. So this is the value for alpha. So that implies that minus 1 minus root 3i minus 1 minus root 3i can be written in polar form as r is 2 cos, okay, cos minus 2 pi over 3 plus I sine minus 2 pi over 3. I hope this is well understood. So see you on the next for more operations in polar form. Thank you.